Hi class, in this video here what I want to do is I want to do a business and economics application problem from section 2.5. And this problem is about a stereo manufacturer. So a stereo manufacturer determines that in order to sell X units, so it looks like the variable X here, X is going to be the units sold and produced. Okay. So to sell X units of a new stereo, so coming out with a new stereo, the price per unit in dollars must be this. So the price function, okay, it looks like it's a function of the X variable. So price is a function of how many units you want to sell. And it's 1,000 minus X. Okay, so what you want to pause here and say, well, why don't we just charge $1,000 for each stereo? That would be great. Well, like how many people actually go out and buy $1,000 stereo, right? Like the cheaper for a normal good, and if you take an economics class, you'll learn what normal good is. Normal good is a good that you would consume more of as your income rises. So for a normal good, if the price falls, people are going to consume more of it, okay? So then the manufacturer also determines that the total cost of producing X units is given by this. So the cost function is equal to 3,000 plus 20 times X. So it looks like the 3,000 is the fixed cost, and the marginal cost of producing an additional unit is $20. That's what it looks like in the cost function here. Okay, so we want to find all these things. We want to find the total revenue, which we'll denote as R of X. We want to find the total profit, which we'll denote as P of X. And then it's going to ask, how many units must the company produce and sell in order to maximize profit? So right there, we want to maximize profit. Okay, so that's going to be what we're going to apply calculus to. Okay, whenever you hear that, like, what is the maximum? That's where the calculus comes in. And then what is the maximum profit that this company will make? And then what price per unit must be charged in order to make this maximum profit? Okay, so let's jump right into it. So first off, what is total revenue? Okay, well, what is revenue, right? Revenue is equal to the quantity you sell times the price you sell it for, right? Like if you sell two units for $5, you make $10 of revenue. Okay, so revenue is a function of X. Well, quantity, that's the X variable you're going to sell, times price, all right, which is P. But what is P? Well, P is a function of X. Like this is the price function. So it's X times $1,000 minus X. Just distributing the X, we get 1,000X minus X squared. The next thing it says is, what is the profit? Okay, well, what is profit, right? Profit is the total revenue you make minus the total cost. Well, the total revenue is this R of X function that you have over here. And what are total costs? Well, if you look back, we have a cost function right here. C of X is equal to 3,000 plus 20X. So it's revenue, which is 1,000X minus X squared, minus cost, which is 3,000 plus 20X. So distribute the negative here, right? So this is 1,000X minus X squared minus 3,000 minus 20X. Well, it looks like here, this just ends up being minus X squared. Like terms here, 1,000X minus 20X gets me plus 980X. Minus our fixed cost there of 3,000. All right, so look, we have total revenue, we have total profit. Now what we want to do is we want to maximize profit, okay? And profit is going to be a function of how many units we're making and selling, okay? So see here, okay, how many units to maximize profit. Well, our profit function, okay, P of X is equal to, we found this minus X squared plus 980X minus 3,000. Okay, so you're going to find p prime of x. You're going to take the derivative. All right, so the first derivative, p prime of x, ends up just getting you, it looks like this gets me minus 2x and then plus 980. So you're going to find now the critical value. So you're just going to set this equal to 0, right? So this is minus 2x plus 980 is equal to 0. Subtract the 980 over. Divide by negative 2, and it looks like if you take 2 divided by 980, you get 490. Okay, but now here's the thing. There's only one critical value. So we don't know right off the bat if it's a max or min. Okay, so to do that, what you're going to do is you're going to use second derivative. Okay, if you take the second derivative, so you take the derivative of the first derivative, you just get minus 2. So to determine if you have a max min, well, look, the second derivative here is just equal to negative 2, which is less than 0. Okay, so it does look like this is a max value. So thus selling 490 units maximizes the profit. Nice. Okay, so look back here. This is some simple calculus, right? We've now found the max units. Okay, so what is the maximum profit now that the company will make? Well, you're going to take this 490 and plug it into your profit function. So this was minus x squared, so minus 490 squared plus 980 times 490 minus 3,000. If you just plug this into a calculator here, you'll end up getting the value of $237,100. Go ahead, an extra 0 there. So the max profit of $237,100 comes from selling these 490 units. So then our final question is, well, what price achieves this? Okay, what price per unit must be charged to get this maximum profit? Well, look, you just got to plug it into your price function. So the price per unit to get max profit is, so you're going to take the 490 units and you're going to plug it into this function. So it looks like you're going to charge $510 per stereo. You're going to sell 490 stereos at $510 each, and that's going to maximize your profit. So again, just looking at this, it doesn't seem right off the bat that the like the algebra, the calculus is really hard. It's just setting it up, knowing what's being asked, things like that. And again, the more practice you do, the better you'll get at it, the easier this will be, and you'll get a chance to practice this on your homework.